Hello everyone. I hope you all doing great. Yeah, so welcome to EDS Multi Online Education. So today we are going to discuss class 10, the first chapter real numbers. Okay. So before starting our session, let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our tools and features we have. So you have chart option with you. You can in the live class you have chart option with you. You can interact with me through chat. And there is expert tutors are there, the live class. You can ask any doubts and clarify your doubts in the session. And there is recording videos are there. You can watch the recording video for your reference before the class. And after the class, you have postcard session is there in there. So you have all the pre material and for exam important questions and all the material you'll get. Okay. So before starting our session, so let's brush up all the knowledge what we learned about the real numbers. Okay, so let's get started. The screen is visible, everyone. Yeah. So today we are going to start real numbers. Before that, so you need to know. So this is the first chapter in the class 10. So before that, you need to know about the basics of real numbers. And the real numbers, it is a branch of the number system. Number system you already learned in the previous classes. So we have different type of numbers are there: natural number, whole number, integers, rational number, irrational number. All these numbers already we learned in the previous classes. Okay. So before exploring to the world of real numbers, so let's recall about the concept of all the numbers, the branch of all the numbers. So the first number would be, once again, yeah, first number would be natural number, natural numbers. How many of you remember that about the natural number? So natural number, so it started from 1. It started from 1, 2, 3 till infinite. These things already we learned in the previous classes. And coming to second one, the whole number. So natural number we generally denote with n and whole number w. What are the whole numbers? Try to recall all the concept. Whole number is nothing but if we include 0 to the natural number, if we include 0 to the natural number, so we'll get whole number. Let's write it here. So 0, it started from 0, 1, 2, 3, so on till infinite. Till infinite. Okay. Yeah, let's move on to the other numbers. Let's move on to the third numbers. That is integers. Integers. What we learned about the integers in the previous session. I mean previous classes. Yeah, integers is nothing but if we include negative numbers and positive numbers and also 0, so you'll get integers. So we'll write -3, -2, -1, 0, 1, 2, 3, the positive values till infinite. If you include negative integers, so we called as integers. So we generally denote it with Z. Okay. Now coming to now coming to a rational number, irrational number. A rational number. Okay, let's write it here. Yeah, let's write it in here. So the fourth one is a rational number. You just recall all the concepts, guys, what you learned in the previous classes. Rational number, so we generally denoted with, if it is in the form of P by Q form, if the number is in the form of P by Q form, let's erase this. Yeah, if it is in the form of P by Q form, P by Q form, where Q not equal to 0, where Q not equal to 0. And what are the other conditions we learned? This is the first condition. And second condition would be PQR integers. PQR integers. What is integers? So just now we learned about in integers. So there are negative numbers are there and positive numbers are there, and zero also included in the integers. So that's why we can take PQ are integers. I think everyone recalled all the concepts. And the fifth one is irrational number. Irrational number. Yeah, you can take examples of rational number like, yeah, we'll write examples here. Examples of 2 by 3, minus 1 by 2. Like if you take any examples, I mean bigger numbers also. Yeah. Now let's recall about the rational number. It doesn't in the form of P by Q form. It is not in the form of P by Q form. And so the conditions are PQ are integers. Okay. For example, if you take examples are root 3, root 2, pi, and yeah, so 1.01, I mean, till so on. So there is no limit where the denominator is not equal to 0, and the form, it is the not never be in the form of P by Q form. So we call it as irrational number. Okay. So we already discussed all these numbers, type of numbers in the previous classes. We are learning since childhood. Okay. I mean, upper grades of 6th class. Now the new number would be, the last number would be real numbers. How many of you remembered about the real numbers? I think everyone already learned about uh, natural numbers, whole numbers, integers, rational number, irrational number, all those things, right? Everyone. Now I'll ask you that what is rational number? Rational number is a combination of, it is a combination of, sorry, real number, it is a combination of rational number and irrational number. Okay. So in rational number, so there are integers, whole numbers, all the numbers is there. So we can simply say that real numbers, it is a combination of all the numbers, natural numbers, whole numbers, integers, rational number, irrational number. The family of all the number system is comes under the real numbers. It comes under the real numbers. You can take any examples of 3 by 4 like this. I mean, that is a combination of rational number, irrational number. You can take any examples. So that is our today topic. So this is the brief introduction of our topic. So the number system, there are natural number is there and whole number. It starts from 0, 1, 2, 3 till infinite. And integers, it is a combination of negative integers and also positive integers, including 0. And also rational number is nothing but it is in the form of P by Q. These conditions are very, very important. Q not equal to 0 and PQ are integers. I hope everyone understood and recall all the concept. Now in class 10, so the first chapter would be real numbers. The real numbers, it is a combination of rational number, irrational number. Okay. So that's why the whole number system is comes under real number. This is the basic introduction to the real number. These are all those things we learned in the previous classes. Okay. Yeah. So in this class 10, so you are not, again, we are not doing all those things. We just moving to the higher grade. So the concept would be complicated. Okay. So in this class 10, you have fundamental arithmetic theorem is there, and also the terminating and non-terminating factors. So how can we write in terminating and non-terminating? All these things are there. Let's understand in depth analysis of the real number. Don't worry, I'm here to explain all the concept. Okay, do one thing, keep a notes and try to take the notes. Try to take the notes, all the concepts. Okay, yeah. In real number, generally, let's take an example. If I give you if I given you normal number, let's see. I'll give you the number like, okay, so divide 27 by 3, 27 by 4. What you will do? For example, if you take, if you divide 27 by 4, what you will do? You can do the long division process. Long division process is nothing but, so sir, we are taking 4 here. So this is a simple example you are given. Why we are here? You are giving all those things. So let's take it here. So 427, 427. Let's understand each and every word here. Okay. I'll write in brief here. Yeah, 427 here. So which number we should multiply? You will get, so 4 times 7, it would be 28. So that would be higher. So if we take 4 6 are, it is 24. It is 24. So if we do subtraction, we'll get 3 as the remainder. 3 as the remainder. Let's identify what are these things. So this thing we called as divisor, divisor, and this one is we called as quotient, coefficient, and this one, whatever after solving this, we'll get remainder, we'll get remainder, right? And what is this one? This one would be dividend. What we call dividend. I hope everyone understood. We know how to do the division process. So we are doing since childhood how to do the division process, what are the remainder we'll get. But these words, I mean, these are variables, divisor, dividend, quotient, and remainder. So these are the things are new to you, right? Yeah. So before starting our session, so simply we can write the standard form. We can write by remainder theorem. So we can write dividend, dividend is equal to, dividend is equal to divisor, divisor into coefficient, quotient plus remainder, plus remainder. I hope everyone understood. Here, if you multiply it, divisor with quotient. So, and if we add remainder to that, so you'll get dividend. You will get dividend. I hope everyone understood. The same method and the same process, the same type. So here there is one other method is there. We called as Euclid division lemma. What we call in the real numbers? I mean the class 10. You can call as a Euclid division lemma. We can find highest common factor for that. I mean HCF for the two numbers. Okay. So what is this Euclid division lemma? How can we understand all those things? I'm here, so I'll explain each and every concept. Observe carefully. The Euclid division lemma. It is in the form of A is equal to BQ plus R. Okay, we just write here. Okay, let's understand about the Euclid division lemma here. Here in Euclid division lemma, understand carefully. Yeah, in the given positive integers as A and B, so there exist the unique integers Q and R satisfying that A is equal to BQ plus R. BQ plus R. Sir, what is this, sir? A is equal to BQ plus R. So we just now write that division method. I mean dividend is equal to divisor and quotient. Let's write it here. A is equal to B into Q plus R plus R. Now it would be matched with the Euclid division lemma, right? A here is dividend. You can compare like this. B here is divisor. Q and Q both are the same word. That's why we can take Q is quotient and R. So that is A is equal to BQ plus R. Now we call this is as a Euclid division lemma. Euclid division lemma process. Okay. So this is the format for every time we can't write by dividend is equal to divisor into quotient plus remainder. We simply write like this. A is equal to B into Q plus R. I hope you get the idea of what is that. Now the condition here is, observe carefully. The condition here is, let's understand the condition. So here condition 0, 0. So in between, I mean R in between 0 and B. So here 0, it would be less than or equal to R and less than equal to B. R less than or equal to B. And here the integer Q and R are coefficient and remainder. Q and R are quotient and remainder. I think you'll get some idea about what is Euclid division lemma, right? Okay, I hope everyone understood. So this is Euclid division lemma. Okay, let's move on. Let's see. Let's write the condition here. So they said 0. So here, what we'll get? What we writing here? Yeah, Q, right? Yeah. So reminder B, RB. I'm sorry, RB, RB. Okay. So what is this R and B? R here is the remainder. Remainder. So remainder either you'll get 0 equal to 0, or else remainder should be greater than 0. That's why we write it as 0, 0 less than or equal to R and R less than or equal to B. B is nothing but divisor. B is nothing but divisor. So divisor every time would be greater than, greater than. So this is reminder. For your reference, I'm writing each and every word. Try to understand. So if you understand carefully, then you can answer the MCQs which were asked in, which was asked in your main examination. Okay. If they asked for condition, what is the Euclid lemma condition? Then you can write this condition. So where 0 less than equal to R less than equal to B, less than B. Okay. Every time remainder it is less than B, less than divisor. Here divisor is 4. Observe carefully. The remainder what we get 3. So 4 is greater than 3. That's why we write the condition like this: R less than B. Okay. So remainder every time it is less than divisor. Okay. Hope you understand, everyone. Yeah. Let's see in textbook what they given. Here we can write the conditions. Yeah. So here integer a and b, you just write like this. Okay. So this is the condition. A is equal to bq plus r. The condition would be a less than or equal to r less than b, where q and r also, and q or r can also be 0. I mean, remember, if we will get 0 depend on the question. Okay. Hope you understand. Yeah. Now that is a reminder. So q we call as quotient and re we call reminder. These things already we learned. Okay. Now the theorem 1.1, Euclid division lemma method, the positive integers a and b exit unique integers q and r satisfying a is equal to bq, and the same method a is equal to bq plus r we need to prove by theorem. So this is the condition: a less than or equal to r and less than b. Okay. So these things we already learn, and also there is Euclid elements are there, and Euclid division algorithm is there, already there, is there in the next upcoming chapter. We'll learn there. Okay. Yeah. Now, yeah. So by using Euclid division lemma, we can find the HCF. How can we find the HCF? Observe carefully here. Observe carefully here. Yeah. Now the condition for HCF. Observe carefully. Euclid division algorithm is a technique to compute HCF. HCF is nothing but highest common factor. So for two integers, if let they given 27 and 335. So these are the two numbers. You need to find the HCF, highest common factor. How can you find the HCF? You can apply by division algorithm, division Euclid lemma algorithm. Okay. So let's solve one question, then you can understand in better way. Okay. Yeah. So observe the question, the example question they given. So you need to find the HCF of 455, 42. 455, 42. Let's do this example. For your understanding, I'm doing this. Okay. So HCF of 455, comma 455, comma 42. Okay. Normally, if they given division, so in rough work, you will do like this. So 42 and 455. So 455, 42 tens are. So you'll get 420. Okay. If you do subtraction, 5, 3. So here 35, it is less than, remainder is less than 42. That's why we can simply write it as, first we just, first step, we can write 45 in terms of, 45 in terms of, let's write it here, 42 into 100, 42 into 100. The remainder what we get here, 35. After doing that, we'll get 42 into 100 plus 35. The same step they write it here. Okay. Now you can do, in rougher, you can do 42. So the division of 42. Okay, let's do it here. 42, we just divided with 35. Now you can write 42 here. We need to find the divisor here. You can take divisor. Now the second step, this is the first step. Now second step would be, so we just write the 42. Now you need to compute the 42. 42. Now 35 ones are 35. You'll get 42 minus 35, you'll get 7. Okay. Now the same format you can write it here. Like 35 ones are, and remainder you'll got 7. Now it look like, B into Q, A is equal to B into Q plus R, the Euclid division lemma method, right? Still we couldn't get the HCF. Now there is a one more step is there. Let's do it here. Okay, now what is the new divisor we got? 35. You can do till you'll get 0. you'll get 0. But what is the remainder we get? 7. So we have few more steps are there. You can take divisor is 35. Sorry, dividend is 35. Now you just multiply with 7 into 1. Sorry, 35. Yeah, 7 5s are. You can multiply 7 5s are. And what is the remainder you'll get? 0. So remainder we got 0. I hope everyone understood. So if you will get remainder is 0, then you just stop it here and observe the divisor here. What is the divisor here get? 7. So that's why the HCF of 455 comma 42, it would be 7. It would be 7. I will explain each and every step. The step 1. So this is step 1. This is step 2. This is step 3. After doing the 3 steps, so we'll get HCF is 7. See, first for 455 and 42 they given. You can do the normal division. So we'll get 35 as the remainder and 42 as the dividend. Sorry, divisor. Okay. So you just write the format like this, and the 35 is the remainder. You can do write in the format of Euclid division. You can division algorithm. Okay. After getting that, so we just take that. We just take 42 as a dividend here. Now 42 we can divide it 35 into 1. So you'll get 7 as the remainder. Still we couldn't get the remainder 0. That's why we can do the process still where we get 0. Okay. After getting that, you can take 35 as the dividend here. Now 35 is nothing but 7 times 5. Okay. Observe carefully, guys. Here we are taking 35. I mean, we are taking divisor 42. After taking 42 here and divisor here, sorry, remainder here, and 35 here and remainder here. Understand the logic? Yeah. So 7 into 5 plus 0 is equal to. So finally we got 0. That's why we can take 7 as a HCF for that particular question. Okay. Hope you understand. Yeah. Let's see what is the HCF they get here. So here they get HCF is equal to 7. HCF is equal to 7. Okay. So you can do by applying Euclid division algorithm, you can find the HCF of two numbers, the highest common factor. Okay. Okay. So observe the conditions here. So reminder, every time you'll if you get reminder 0, you just stop it here and write the divisor. So you just follow these are the steps you should follow. Okay. First you can do the division algorithm. Observe if you get reminder 0 or not. If you couldn't get the reminder, then you can proceed with the next step of Euclid division algorithm. Still you couldn't get the remainder 0, then you can proceed the further step till you'll get remainder 0. Till you will get remainder 0. Then stop it here and write the divisor. That's it. Okay, I hope you will get some idea about that Euclid division algorithm finding HCF. Yeah. So let's solve the example 1. Here example 1. Use Euclid algorithm to find HCF of 4052, 12576. These are the huge numbers. There's a huge number. How can we solve? How can we solve? So first, you can take the bigger number 12576. 12576. If you multiply 4052 into 3, so you will get the remainder 420. Okay. Still, we couldn't get the remainder is not equal to 0. That's why you can take 4052 as a dividend, and you can multiply with the remainder for 420 into what? You'll get remainder 272. Still, you couldn't get the remainder is 0. 272 is not equal to 0. So that's why you can take 420 as a remainder. Sorry, 420 as the dividend and 272 as a divisor. The process is going on where you'll get remainder is 0. Okay. After doing all the steps, finally here I get remainder is 0. So if your remainder is 0, then you can observe where is the quotient. Divisor here is 4. That's why the HCF of 12576 and 4052 is equal to 4. So there is a lengthy process where you will get 0, the remainder 0. You just stop it here and write the divisor. That's it. Okay. So observe carefully the statement here. The remainder has now become 0. So our procedure stops since the divisor at the stage is 4. After getting remainder is 0, you just stop the procedure and you can write the divisor as usually. That's it. Okay, so be patient and while solving. Why? Because so observe carefully in this question. So how many steps you will get? 1, 2, 3, 4, 5, 6, 7. After 7 steps, after writing the 7 steps of the procedure, you'll get remainder 0. The HCF is 4. Okay. Yeah, you should be careful in finding that HCF. Okay. If you couldn't get the remainder 0, you don't stop it there. Till try to do till last second. Okay, where you get remainder 0. Okay. Now let's solve the second question. Read the second question, second example. They given show that every positive integers is of the form of 2q, and that every positive integers is in the form of 2q plus 1, where q is some integers. Understand the question carefully, guys. Here what we need to prove. The positive even integers. What are the integers? Integers is a combination of negative numbers and positive numbers and 0. But here they asked for only positive integers. Positive even integers. Right? Positive even integers. Yeah. So positive event is in the form of 2q. What is a 2q? Let's take that. Let's write the example here. So here a is a positive integer. A is nothing but dividend, and b here they given 2. Okay. Then you apply the Euclid lemma. So here q greater than 0. Q greater than 0. If you take r values 0 and 1, 2, 3, all those things. So the condition you will get 0 less than or equal to r less than or equal to 2. Okay. Okay. Let's do it here. For your reference, I'm doing here. Okay, so the form they given 2q. The form they given 2q. Example 2. Form they given 2q. But what is the condition for Euclid lemma? So we just write like a is equal to b into q plus r. Here they given only 2q. If nothing else, you can take 0. Right? So the question we can rearrange like this. The question we can rearrange like this. 2q plus 0. Here in the place of b, 2 is there. The place of q is there. And in the place of r, 0 is there. We just compare like this. A is equal to bq plus r. Okay. Now that is the question. Here if you take r is equal to 0, then you'll get 2q. If you take r is equal to 1, let's substitute r is equal to 1 here. Now a is equal to 2q, r is equal to 1. So 2q plus 1 you'll get. 2q plus 1 you'll get. So that's why the odd integer r is equal to 0 and r is equal to 1. So the limit would be you can take 0 less than or equal to r and less than 2. So you'll get a is equal to 2q or 2q plus 1. I hope everyone understood. Only thing is you just compare with that, guys. That's it. They given 2q as the question. If you apply compare with the Euclid division lemma, a is equal to bq plus r. Now I compare like this. In the place of 2, b is there. In the place of q is there. In the place of r, 0 is there. Okay, that's why now if r is equal to 1, this is the condition for this case. If r is equal to 1, remainder is 1. So we'll get a is equal to 2q plus 1. If r is equal to 0, you'll get a is equal to 2q plus 0. That is a is equal to 2q. A is equal to 2q. Hope you understand the example. The similar way, the third example, show that any positive integer, the same question, 2q plus 1 to or 4q, 4q plus 1, 4q plus 3. And here q is where q is and some integers. Now you can compare with the general form. What is the general form of Euclid lemma? Let's write example 3. Example 3. What are the given term they given? 4q plus 1. Okay. Now you can compare with the general form. A is equal to bq plus r. In the place of b, what is there? 4. In the place of q is there. In the place of r, 1 is there. Now we can confirm if r is equal to 1. If you take r is equal to 1, now you will get a is equal to 4q plus 1. If r is equal to 3, what we will get? A is equal to 4q plus 3. In the place of r, you just substitute 3. So that's why 4q plus 1, 4q plus 1 you will get. So you can take some random guess of 0. Remainders. If remainder is 0, you'll get 4q. Yeah, 4q. If you get if you substitute remainder is 1, r is equal to 1, then you'll get 4q plus 1. If you substitute 4q, r is equal to 2, you'll get 4q plus 2 like this. So these are the questions. But in the question, what they're asking, so we need to show that only positive integers. Sorry, odd integers. Odd integers is nothing but we can take only 4q plus 1, 4q plus 3. Why? Because 1 and 3 are integers. I hope everyone understood. Try to understand, guys. Why? Because it is not an easy concept. It is not an easy concept. You just compare with the Euclid division lemma. Euclid division lemma. Okay. Yeah, the same question which would be reflected with the other integers in the exercise part. We'll do the exercise part. Don't worry. In that, you can revise all the topics what you did in example questions. Okay. Okay. Let's move on to the fourth example. Read the question. The fourth example. A sweet seller has 420 burfis, kaju burfis, and 130 badam burfis. So she want to stack them in such a way that each stack has the same numbers. They take up the least area of the tray. What is the number of that can be placed in each stack? Okay, so there are some trays are there in that particular trays. In that particular trays, so you can fill the equal number of kaju burfis and badam burfis. Like if you take kaju burfis 4 and badam burfis also, you can take 4, the same number. Okay. Similarly, how many stakes did you get? I mean, how many trays and number of, what is the number of that we place in each stake for the purpose? How can you solve this? We can solve it by taking HCF of, so this is example 4, right? Yeah, example 4. HCF of, how many kaju burfis are there? 420 and 130. So we can take the HCF of 420 and 130. Okay. How to find HCF? I think we already learned till from Euclid division lemma. So we just write Euclid division lemma here. Now A is equal to BQ plus remainder. Okay. Yeah. Now let's write it here. Yeah. First, we just take the first step. You can do the process till you'll get remainder is 0. Okay. If you get remainder in the first step, then you can just stop it here. 420, how can we write? Let's do it in 130. We can do the division here. Okay. 130 times. Yeah. So here 130 times 3 is, so you'll get 390. So you'll get the remainder is 30. Okay. I'm doing here once again. I just do in brief manner, then you will understand the concept really well. Let's erase this. Okay. So first 130 and 420. Okay. So for 133s are, you'll get 390. The remainder we get 30. Now the next step would be you can take this 130, you can take here. The divisor comes by, because we couldn't get the remainder is 0. The remainder we got 30. So that's why you can take process is repeating till you get 0. 0 is the remainder. Now 30, 39s are 3 nines are 36, right? Yeah, that's why I'm taking 360. So you'll get again 30 as the remainder. Now this 30, we couldn't get the remainder 0. That's why this 30 comes under here. So again 30. Now 31s are 30. Finally, we got remainder is 0. If you couldn't get the remainder 0, the process repeating like that, the divisor 130 comes here. I'm sorry, I taken 390. Oh, I'm sorry. You just take 130 here. I'm sorry, everyone. Yeah, so here you can take the divisor 130 comes here. The divisor 130 comes here. Okay. Yeah, let's do it here. Yeah, 130. So 30 times 34s are 120. Now you'll get 10 as the remainder. The divisor comes here. Still you couldn't get the remainder 0. That's why, what is the divisor here? Now 30 is the divisor. Now 30 comes here as the dividend. Okay. Now 10 3s are 30. You'll get remainder 0. Finally, we got remainder 0. We just write all the steps here. So 420, how can we write 420? B here, I mean the divisor here 130 and the quotient here is the 3. And what is the remainder we got? I am writing in Euclid division lemma method. The remainder we got 30. So just write 30 here after doing that. Now we couldn't get the remainder 0. So that's why. That's why. So 130 we can write here. 130. 130, how can we split that 130? We just write it like 30 into 4, 120 plus remainder 10. Remainder 10. Still we couldn't get the remainder 0. That's why the second, this is second step. The third step. Okay. Yeah, the third step. 130. Now 30 is the dividend. 30 we can write it as 30 we can write it as 10 into 3. The remainder finally we got 0. Now you just stop the procedure here and let's try the LCM here. LCM of, sorry, HCF of 420 comma 130. So we'll write the divisor. What is the divisor here? 10 is the divisor here. So that's why the HCF of 420, 130, the Kojubar is you can take that stakes of 10 rows. Okay, you can arrange like this. So 10 is the HCF we got. You can arrange like this. I hope everyone understood. Still have any doubts? Finding HCF. You can do the maximum number of steps. If you couldn't get the remainder is 0, you just do the procedure and till where you will get remainder 0. Then you just stop it here and write the HCF as divisor. Here divisor is 10. Divisor is 10. That's why you can write the divisor is 10. The number of stakes would be 10. Okay. Okay. We'll solve the 1-2 questions of Euclid division lemma. Then we'll end up the class here and we'll solve the other questions tomorrow. So the first question in exercise 1.1. Let's write exercise 1.1. Okay. So in exercise 1.1, the first question, the first one. Okay. Let's solve the first one. What is the first one? You can find the HCF of 135, 225. Now, can anyone please, what are the numbers? 135 and 225. 135 and 225. 225. Okay, follow the Euclid division lemma method. First, you just write the steps like, you just write the formula of what is Euclid division lemma? That is A is equal to BQ. Once again, A is equal to BQ plus R. So where A, okay, don't need to write the condition. Okay, no, you just write the format like this. So first step would be, the step 1 would be, you can take the bigger number, that is 225. 225, how can we write in terms of 135? Let's do it in rough part. So let's write it here. 135, 225, 225. 135 times 135 into 2. So you'll get 260, above 270. So that's why we can take 135 times 135. So you'll get remainder is 0. 7 comma 2, 90 you'll get. Okay. No, you couldn't get the remainder 0. Let's write it here. 135 into 1. 135 into 1. And the remainder we got 90. Okay. Now the divisor comes here like 135. Okay. I hope everyone understood. Now 90 in 9 table 1, 90 table 135 is there or not? 90 table. 90 table 135 is there or not? Yeah, it is there. So 9 tens are 9 11s are sorry 90, right? Yeah. So 90 135. So 91s are 90. So 35 minus you'll get 45. Okay. Again, we'll couldn't get the remainder is 0. That's why we just write 135. We split it like that. 135 we split it like 90 into 1. The remainder we got 45. Still we couldn't get the remainder 0. That's a process would be repeating. How we repeating the process? Let's write it here. Now the divisor 90 comes here. So 90 Okay. Now 45 twos are 90. So finally we got remainder, right? So let's write it here. Let's write it here. Yeah, 90 we can write it as the step 2, step 3 here. So here step 2. So this is step 3. 90 we can write it as 90 we can write it as 45 into 2 plus 0. Finally we got remainder 0. Now observe what is the quotient. So here, I mean, sorry, divisor. The divisor is 45. So you can write the HCF of 135 and 225. 225 is 45. 225 is 45. You just end up here. That's it. You need to find the HCF of the two numbers like this. I hope everyone understood. You can do the, if we couldn't get the remainder 0, so you just do the, take the divisor here, 135. And after doing that, you will get 45 as the remainder. Still you couldn't get the remainder is 0. Now you can take divisor 90 here. So you can do the number of steps till you will get remainder is 0. After this step, I'll get remainder 0. That's why I can confirm that divisor is 45 is the HCF. 45 is the HCF. I hope everyone understood. Okay, so remaining questions, I mean, I'll give the remaining question we'll do in the next session. So before that, so let's summarize what we learned till now. So we started from the number system. I mean, the whole number system, what we learned in the previous classes about natural number, whole number, integers, and all those things. And already we learned about rational number and irrational number. The rational number, it is in the form of p by q, where q not equal to 0, p, q are integers. And irrational number, it is not in the form of p by q. And that the last form is, the chapter name is real numbers. The real numbers, it is a combination of rational number, irrational number. The whole number system comes under real numbers. Okay, so that is the chapter main theme. So in real numbers, the first concept would be Euclid division lemma. The Euclid division lemma, you can write the integers a and b, and unique integers r, q and r, you can write in the format like this: a is equal to bq plus r. The condition is, why? Because the condition in the previous year they asked the condition 0 less than or equal to r and less than b. Okay, where q and r are quotient remainder. Why? Because if you take the remainder theorem here, the dividend is equal to divisor into quotient plus remainder. Okay, by applying the same logic here for the Euclid division lemma, a is equal to b into q plus r. Okay, yeah, these things already we learned. And also we find HCF of two numbers by taking Euclid division lemma, the process like this. All these things we learn in this particular session. Okay, how to find the HCF and all those things. And we solve the few example parts, example questions also. How to find the number of trays, I mean, Kojobar fee and all those things. So here we got, after doing Euclid algorithm, so we'll get the HCF would be 10. We can arrange the stacks of 10 in each tray. Okay, yeah. And yeah, these things in today's session we learned all those things. Okay, yeah, so I just end up here, guys. Thanks for being here. Let's meet on the next session with the other problems of the exercise 1.1. Okay, before that, try to revise all the concept before coming to the class. Okay, thanks everyone. Bye bye.